Hey everybody, today we'll do another math problem. And again, we will do another math problem and we will do some integration by parts again. And I will try to do it in this writing pod. And I will try to do the best I can to be kind of organized, right? And at the same time, if you have not subscribed yet, subscribe to the channel and give me a like if you learned anything in this video. So today we will actually do we will do a problem out of this book. Right? So we will do a problem out of this book, Calculus, the Classic Edition. And still, we will be doing the problem on exercises 9.1. And it's problem number 9 in this book. So, so it's problem number 9. And let me use a different color. Let's see. I guess that is fine. I guess if I pick green. Alright, so okay, so the problem is as follows. The problem is as follows. I will be doing still the same thing, indefinite integral. We will do indefinite we will do the indefinite integral actually doesn't say anything. He just says evaluate the integral. But we know that it's indefinite because it doesn't have any limit of integration. So he says evaluate the integral. Right, and again is 9.1, and that is number 9, right? Okay, so let me just clear that because I need that room. But so we evaluated the integrals, right? And the integral is as follows. It says integral of x squared cosine x, right? And of course dx, right? So based on this, right? Based on this, okay, so based on this, we can actually say that u is equal to x squared, du is equal to 2x dx, right? Then we can say that Okay, so let me just rewrite the definition of the integral back here just to refresh it, right? So the integral of u dv equal to u v minus the integral of v du, right? I guess we're familiar with that formula, so that's what we're following, right? So just to make it sure, we're following this here. So we're following this formula, right? Right? So the integral u dv equal to uv minus the integral of v du, right? So, okay, so with that already kind of clear up of what we're doing, we will have to find, so we have a uv, right? So we have to find uv. We already let u is equal to x squared. We need to find v, right? And then because we have a dv, we have to find the integral of a certain, of the other variable, right? That we actually let in v equal to, right? So here is when it gets kind of interesting, because when you actually integrate the cosine and sine, there is some special integral for this. So we already let u equal to x squared, correct? Now we have to let dv is equal to cosine x, right? And then we integrate on both sides of this, right? So when we integrate on both sides, we get what? We get v is equal to sine x, right? To sine x, right? So technically it's equal to sine x, right? So we integrate, right? Both sides, we get a v is equal to sine x, right? Now, with that, we can actually come in here and replace and substitute those values in the formula, and we can say that actually I love the formula, but the integral of u dv equal to uv minus the integral of b du, right? Okay, so we have this formula. We already know what the formula. So we have the values for the formula now, not the values, but the correct expressions, right? So we come here and we said, okay, so what is u? Well, u is x squared, right? Right? And what is du? Well, du is equal to 2x dx, right? So we have that, which is right here. And then we have a b right here. Well, what is b? We just found it. It's sine x, right? And remember, just by looking at this, we have to integrate twice in here. Again, why? Because we have an x squared in front of that cosine. So it's important to kind of analyze the problem before you start doing it, right? Okay, so now we do the following. We come here and we just substitute. We substitute what? We substitute u, which is what? Is x squared, and v is equal to sine x, right? Minus the integral of what? Of minus the integral of sine x. And I can put parentheses here, and I can put 2x dx, correct? Okay, so now I can rewrite, I can actually rewrite this and bring it to the front here, right? In front of that sign right there. And I can say, okay, I can say x squared sine x minus the integral of 2x, and I can leave the dx hanging over here. So I brought that 2x in front, right? And matter of fact, you know what? I can actually, well, let me just do it step by step. So I can actually say, okay, sine x dx. All right. So now you can see that we can see that this is hanging. This is 2x's in front of the sign. Okay. Okay. So let's go to the next page. Okay. So now what we can do is we can put that into the front here, and that will be the next step. We will pull that 2 in front of the integral, right? And that is going to be equal to what? It is going to equal to the following. It's going to equal to x squared sine x minus 2 the integral of cosine x dx, right? Okay, so now it seems like we already took the first integral, right? But I am missing something here. Let me just, okay. I am missing an x. We have to be careful here. Alright. Alright, so we have this x, so we have to we took the first integral. We need to integrate again. We have this dx hanging with y because we have this x here. We have this x in front of the cosine. We have the dx. We need to get rid of it. At the end, we should not have a dx. We should have a plus c on it, right? So how we do that? Well, I come over here and I said, okay, I said x squared sine x minus, right? And I put a 2 here. But remember, before that, let me just, okay, do the next step, right? So let me just erase this. Okay, so let's do it step by step. Okay, so now we need to follow the steps again, right? So we need to let y, because we have an integral here, we need to get rid of this integral, right? So we have to integrate again. So that was the first integral. Now we're doing the second one. So now we let u equal what? Equal x, right? So du is equal to dx. Now you can see right here. Now you can see that du is equal to dx, right? That means what that mean is that the we getting close, right? We getting close. Why we're getting close? Because we don't have no more variables, right? So du is equal to dx, right? So du equal to dx, right? And that's what we want. Now, what is b? Well, that's what we want in the x term. Now we have to find the, let cosine, let's dv is equal to cosine, right? So now dv is equal to cosine x, right? Now we integrate both sides, right? We integrate both sides on this, right? So when we do that, let me just, okay, so let me just do it. Cosine x, right? So when we integrate that on both sides, we get that v is equal to what? Now I am taking the integral of actually, no, sorry, nope, make a mistake here. I'm telling you, gotta be careful with this. See, this should be sine. Right? Sine x. And also this should be sine x because that's what previously, you gotta go back and check. See, I had it here. If you don't go back and check, you might put the wrong thing in there. So you do that, and then you actually let u equal sine x. Then when you take the integral of that, then it's negative cosine x, right? So the integral of sine, x is negative cosine x, right? Now that I have this, I can actually start writing everything, and it's going to, we gotta be careful what we're doing here. So we have x squared, and then we have sine of x minus, right? We put the 2, we factor out, and then we put set of brackets like this, right? And inside we have u was x, right? And v is actually negative cosine x, correct? And put it in parentheses like that, right? Because we're doing it step by step. I could just multiply that, times negative and change that to a positive. But, I want to follow the steps so you can learn too. That's the whole purpose of this video, right? So, okay. So, this is the whole purpose of the whole channel anyway. That's, I am not here to, I'm here to make sure that you guys understand, right? Right? So, okay, so now what happened here? So we have u and v, right? Now we minus the integral again, right? And du equal to dx, correct? So du is equal to dx, and v, we have it right here. So, and v, we have it right here. So now, well, what I can do here is simply put parentheses minus cosine x, right? And close the parentheses to make it sure that it's a negative in there, and put a dx, right? Which is du, right? Now, let me see. I'm gonna get rid of that. So now that I have this, right? Now that I have this, now that I have this, all right, now that I have this, right? So what I can do, now I can do some stuff here. I can change that to a positive, right? And I can just make it right here. I can make it right here, and I can make it like x squared sine x minus 2, right? And I can actually say x minus cosine x plus, see, now I got this plus right here. So plus sine of plus cosine x dx, right? So now, right, right, so now as you can see that cosine x dx, right? So now, as you can see that the integral of cosine is sine, correct? The integral of cosine is sine. So therefore at this point we should have what? We should have what? We should have, at this point, we should have what? We should have x squared sine x minus 2, right? And then here we can say that, you can factor that minus out and just minus x cosine x, right? And I still keep it in the bracket. So because that too is going to be distributed inside the brackets, right? So the integral of sine, the integral of cosine is sine, so I get plus, right? Plus sine x, right? And that is equal to, well, that is not equal to yet, right? But that is the integral of that. Now, all I have to do is multiply that. Let me just change colors. Okay, so now what I have to do right here is the following. So I said x squared sine x, right? Multiply that 2 inside, and I get what? I get minus, no, I'm sorry, I get plus 2x cosine x minus what? Minus 2 sine x, and because it's an indefinite integral, we just add a plus c, right? And that is the answer. So the answer is sine squares, the answer is x squared sine x plus 2x cosine x minus sine x plus c. That is the answer, right? So yes, I hope you learned something in this video. If you do, just give me a like, and I will appreciate that, and that will be motivating me, to put more videos in the future. And as you know, we are the Conservative Engineering Academy. We learn here because Jesus is good with us. He is the one that gives us the knowledge. And without him, we cannot do anything. That's what the Bible says. He said, without me, you cannot do nothing, cannot do anything. So basically, it's nothing that we can do without his help. All right. Thank you for watching, and God bless.